Yeah, thank you very much. Thanks for coming. So first of all, I want to say that I don't claim I know everything, right? So this is a presentation I put together just to share my experiences in the last year working in the AI-related projects and doing delivery with the AI components. So actually, just before we start, maybe it's a good idea to introduce myself. My name is Harry. I'm a principal consultant at Next Paradigm. In the past, I was working at ThoughtWorks, so it's familiar for me. I worked at ThoughtWorks for nearly 7 years. I worked in different fields, QA strategy, agile transformation, and business agility. In the last couple of years, I'm more focused on agile transformation and business agility. But I always have a soft spot for the QA, and I always believe that if you don't build your quality in your whole organization, it's really hard to achieve agile delivery, and it's really hard to meet your customer demands. As I mentioned, I worked in AI projects in the last couple of years. I think they're coming more and more. We are hearing more and more. It's actually becoming a hype a little bit, and it's really hard to distinguish between the reality and the dreams and the pipe and actually the hype. So what I will try to do here is getting some insights maybe around the things which I did and seeing some of the pitfalls I saw, sharing with some of the pitfalls I saw with the AI and testing during this time. What is AI? Does anybody have a clue? It's everywhere. It's on the paper, it's on TV, it's on the magazines, it's on internet. What is AI? Anyone?
Machine learning about a problem without explicitly coding how to work.
Yep, machine learning, yep. Anything else in reviews? What AI is? Just we hear like 20 times in a day. Just we have lots of companies claiming that even on your phone right now, you probably have 20 or 30 apps using AI. No? All right. So this is one of the, I think, definitions of AI is from Poole, Markbot, and Goebel. An artificial intelligence that perceives important, that actually understands what's going around, its environment and takes actions that maximize its chance of success at some goal. So I think three things are important here. The artificial entity should perceive its environment and take actions to maximize its chance to succeed at some goal. So we need a goal, we need a behavior to maximize the chance, and we need an entity that perceives what's going around. So to say in a very nutshell of definition of what artificial intelligence is, but does it even exist? So do we actually have AI products right now in the market? I know it's a bit controversial. I'm talking about AI and building better quality, but do we really have AI in the market?
Yeah, all the voice assistants.
Mm-hmm. Okay. Yep.
We do have some automation tools as well. The Blue Prism.
Yeah.
And, a couple of others.
Yeah. So I think one of the, and this is not about AI, this is about testing, but I think it's good to touch base with that. One of the common mistakes that we do a lot when we're talking about AI is we think it's one thing, one block, but this actually has multiple blocks. And one of the simplest ways of separating into two is general artificial intelligence and narrow artificial intelligence. So narrow artificial intelligence is a product, is an entity who does things well, like voice recognition, right? So you have a program, you have an entity, you have an app that actually understands the voice and recognizes your voice and acts accordingly. But probably that program can't play chess, can it? You need another narrow artificial intelligence for that. So the artificial intelligence we see mostly in the movies are general artificial intelligence. So an entity who can think and who can act on multiple domains and different domains and cross-reference those things and come up with its original thoughts. So if you look into the market right now, I think nobody can claim that there is general artificial intelligence going on. But there are lots of narrow artificial intelligence applications. One thing that I think we need to be careful about is the AI effect. That happens a lot. So basically, onlookers discount the behavior of an artificial intelligence program by arguing that it is not real intelligence. So if you look into the history about the discussions around AI, if you go back to, I think, 50s or 60s, people are talking about computers won't be able to play chess. And computers start to play chess. Say, well, chess is not really AI. And that people start to talk about, well, computers won't be able to recognize voices. Well, computers start to recognize voices, and people say, well, that's not really AI. And then this came the pattern recognition and image recognition. People are claiming in the 90s, computers won't be able to recognize images or faces, but they started to do that. And then people said, well, that's not really AI. So that's actually an effect that you see a lot in the market. So things that we think that, that will be AI, in the future when people achieve it, what you will see is there's a tendency to say, but that's not real AI. So just be careful about that when we're talking about what is AI and what's not AI. Any questions? All right. As I said, I won't go into details, but it has multiple layers. So neural networks is not AI. Deep learning is not AI. Image recognition is not AI. They're just multiple layers. You create neural networks, and you nest them. You create deep learning mechanisms, and you apply it to image recognition, and you recognize images. But it's much more than that. And it is, I think we don't have enough time to cover it in all aspects, and I think it's not the focus of this presentation, but it is much more than that. All of them are AI, but separately they are not AI. They're building blocks. Yep.
So would you say AI is a combination of all these pieces?
Yeah, I would say so. I mean, if you have neural networks, what is it good for if you don't actually point them to a goal? And if you don't have deep learning in them, engraved in them, if they are not learning, so what's the point? And if you are not solving a practical problem, it's great that you have something that learns, but it's not solving any problem. So what's the point of that? Yeah. So QA challenges. I thought about that actually a lot, and it is not really easy to wrap the QA challenges into a couple of topics, but these are the things I came up with. I think the first challenge with the AI is ambiguity, testing AI products, I should say. The first challenge with testing the AI products is ambiguity. The second challenge is training data, and the third challenge is rapid improvements in integration and solution. And I will go into the details on each and every of them. And you can stop me and ask questions anytime you would like to. So ambiguity is interesting. Normally when you kick off a project, and it depends on what kind of a process you are using, but you can kick it off with project kickoffs, with inceptions, or other different methods. You more or less know what will happen during the project, and of course there's some ambiguity, but you know, okay, this is what will happen, and this is how the product will behave, and you say, well, this is actually what we expect from such a behavior, so this is a closed system, and etc. But with AI, it's all frontiers. So still, if you look at the market, it's really hard to find out, at least I have difficulties to find out the practical applications of how to test artificial intelligence. There are lots of papers coming from universities. There are lots of research papers as well. But when it comes to practical applications of it, they're academic, how scalable they are, how cost-effective they are. There are still lots of questions around it. So there's still there are lots of ambiguity in there. And as you will be in the frontiers of the software development, it will be not easy to test the artificial intelligence based products. You need to probably discover lots of things yourself. You need to think about how you will be covering some of the aspects of it. So frontiers is definitely something, especially not only QA, but if you look from the business perspective, normally when you are defining or designing a business process, you know step by step what will happen. But if you have an AI component in it, then the design process completely changes. So the challenge is not only from the QA perspective, but the challenge is from, of course, development perspective, from BA perspective, but also from QA perspective. You have the frontiers challenge. Non-deterministic behavior modeling. So we have non-deterministic behavior, I think, in conventional software as well. There are a couple of very famous articles written about that. One of them is I can think about straight away, Malcolm Fowler's dealing with non-determinism in tests. But this non-deterministic behavior is happening because of the because of environment, not because of your product. So your environment changes, your test fails because of your response time, and et cetera, and et cetera, and et cetera. The non-deterministic behavior we are talking about is exactly because of your product. What I mean by non-deterministic is you have one test, same conditions, same input, you have result A, and later you have the same test, same conditions, same input, and you have result B. Because the behavior of your product has changed. It learned. It recognized some patterns and it changed how it's working. So this is hard. There are different ways of testing it. If you're interested, you can look into probabilistic testing. So what they do is, in some universities, there are some research going on. So they basically map the probability of different behaviors, and they look at the data, test data, and they analyze it, and they say, okay, if this is the test data and this is the behavior, the starting behavior, probably that's what the artificial intelligence will come up with. But still, it's still a big challenge because you need to change your mindset completely. And there are no standards. Even now, if you're talking, well, imagine that when Selenium was out first, there were a couple of other platforms, I think, to do test automation. And right now, we more or less have some standardization, I think, test automation frameworks around, you have JUnit, if you're using Java, you use JUnit, you have Selenium, and a couple of more. But there's no real standards right now. I mean, you can use the conventional methods, you can use the conventional frameworks, and you can create your own structure around it. But except some maybe limited support from platforms like TensorFlow, Azure, there's no real standards around. At least I don't know one standard which actually prevails in the whole market. So you might need to find yourself. You might find yourself actually trying to find your way around the standards and trying to find what's the best for you. So just a bit challenge. So those three things I think adds up the ambiguity to an AI project from the testing perspective. Any questions?
By definition of a test, testing and non-deterministic behavior would be test, meaning, you test something really, you say, okay, yay or nay. Even, that's the definition of it.
Mm-hmm.
So we are talking not about testing, really. I'm not sure what we are talking about.
Mm-hmm.
It's not testing, it's classic definition.
No. I think what we're talking about here is you don't have a system that behaves or you expect to behave each and every time the same way when you put the same data. So if you click a button, it doesn't open a page always. It doesn't open the same page always. When you click a button, it might close the page or it might show you something else because it learns and it changes its behavior depending on the training data you provided. So from the functional level, I think from low levels, from unit testing level and from integration level, it shouldn't be that hard. It's not very different. But from the functional level, if you look at the user journey, so it's really sometimes hard to understand how your product will behave because the behavior of the product from the higher level user journey changes a lot depending on the test data you feed into it. Did that answer your question?
Yeah, no, it's fine. I was just thinking it's just difficult to think about it.
It is.
Ultimately, the only way that I see to verify the behavior of an AI is building another AI and testing by redundancy.
Correct.
One of them has to be correct.
Yeah.
Then you have
Yeah.
If you test on a spit broad,
Yeah. And I'll not be talking about how to use AI for testing. There is another different subject, I think, but there are lots of things going on in there as well. I think there's more maturity in there.
So you'll either end up with a really good test framework or a machine that can play Go, one or the other.
Yes. Sorry.
Can you give a concrete example of a system where one of these non-deterministic tests and what the thing testing thing you are testing would be?
I'm just making this up right now.
Yep.
Hopefully I will be able to. Imagine that you have a system, image recognition system, which works in the parking lots or which works in the streets, in the main motorways, and needs to recognize the cars, the models of the cars. If you run it in Saudi Arabia, which doesn't rain, but doesn't rain a lot, I think, it doesn't snow, you will have a different result from running it in Norway, which snows a lot. So in Norway, probably your car will be covered with snow. In Saudi Arabia, it won't be. So if you train your AI, different AIs, right? One is trained with Norway training data, and the other one is trained with the Saudi Arabian training data. And if you provide these two trained entities that's the same testing data later, then you might actually have completely two different results because they learned it differently. I don't know if it became a good example, but
It doesn't seem substantially different from getting different results from a program, from a traditional software program, starting with different inputs.
why do you think so?
Well, I guess you're testing the AI, or are you testing the protocol you use to build the AI?
Mm-hmm.
Because if it's the latter, then you've got two different inputs. One's the Norway input and one's the Saudi Arabia input.
Mm-hmm.
And you get different outputs. That's not a surprise.
But you change the program itself, isn't it? I mean, if you look into for example, if they are built-in neural networks, you change the structure completely differently, right? Depends on the data you are feeding, the network completely, the structure itself will change completely different. And at the end, what you will find out is you will have actually completely different programs, don't you?
Yeah.
So the construct of the program changes.
Maybe we'll argue about it offline.
Okay. Yeah. Really would like to know what you think about it.
Sure.
Yeah. Any other questions?
Well, going back to the definition of AI,
Yep.
if we say it takes actions to maximize some goal, so one way of testing that would be clearly you put that to identify a goal if it has a different behavior than the baseline.
Yep.
You will have to see if that behavior is actually a maximization points further to the goal.
Correct.
than the previous
Correct.
one. However, if you are able to compare two behaviors and then see which one is closer to the goal,
Yep.
and you can do it without AI, probably you're better off writing a system that uses that linear algorithm.
Probably. I think one of the pitfalls over there might be if you are treating AI like a black box, then correlation doesn't always mean causation. So you might actually get better results, but is it really because AI works? Is it because something else? You might now know that. That might be one of the pitfalls. But yeah, I think the simpler the system, the better it is, if you ask me.
Isn't testing an AI more like training AI? That's what I always tend to think of it. I mean, if you have like a component that recognizes production goods that, for example, always should look the same, how does the program learn? The program learns by us or some other intelligence telling
It is.
this is correct, this is false, this is correct, this is false, then it starts learning.
Yeah, it is.
So
And
it's more like a training exercise than a testing exercise.
it is, and I will touch base about the training data as well. I think the challenge with that is you might not always have the right training data. You might need to find the best way of doing that. I'm actually talking about the next slide I will be talking about. But you might not always have the right training data, or you might need to make up the training data. So how will you know that actually behaves exactly the same in the market or in the production?
So actually, in a meta sense, that's almost saying that the whole thing of AIs is deterministic, and he who has the greatest training data set is actually going to win the game no matter what. And yet we're
Well,
starting
there's
to
still-
see the emergence of a few different areas where it's not the ownership of the data set that's actually starting to create the best results.
I think up to some extent that's right, to my knowledge. But there are also different node architectures which might actually impact that as well. And there are different propagation methods, there are different learning methods in there too. I think they are deterministic, but I basically don't know how deterministic they are. Training set is, of course, very important. Training data is very important. But if you have different architectures and if you train them differently, maybe they will react differently.
Yeah, I think there's also a trend where we try to do away with the training sets. So we get, like, I actually watched, if you're on Netflix, you've got Netflix, there's a really good documentary about the Go, about how the top human player was beaten by an AI. And in that one, they were saying how AI was evolving and how basically it was like two AIs training each other. And what they did, once they basically did, demonstrated that they could beat the best human player, they then went back and with the original chess algorithm that they did, that beat Garry Kasparov all those years ago. So they basically did a version of that using their new techniques. Mm-hmm. And apparently it came up, much faster, at grandmaster level than the techniques they were using.
That works pretty handsomely with narrow AI, but for the...
But the second time they did it, they actually made the AIs train each other to play chess or Go or whatever it was. So there wasn't any... the training data itself wasn't like human-made. Yeah. And I think one of the advantages of that is if you have a flaw in one of them, it just propagates. And you can actually find out the problems very easily because it just surfaces straight away. You get a lot of iterations.
Yeah, exactly. And very quick iterations. Scott? And training data. Yeah. In one of the projects I was involved in there was basically not enough training data. It was a new product, and it was an image recognition project, and I can't give lots of details, but they're basically taking the picture of a product and they were saying how good the product is, as it's really made well, or etc. They didn't have any training data. So what they have to do is they literally have to go and take pictures one by one and just create that training data. So you might not have enough training data when you're testing your AI as well. So if you don't have training data, so how do you know actually the algorithm behind that really works? So that's one of the challenges. The other one is if the data are realistic, because at the end what we want to do is we want to put our products on the market, and that should be realistic data. It's very easy to create your training data in a laboratory which doesn't have any flaws, and in real world we have lots of flaws, and we have distorted images, we have broken products, and etc. So when you are creating your training data, just to make sure that your data is realistic, so get it from the production as much as you can. Of course, there are challenges. If you are creating a new product, you have two options. One of them is before you release it, if you are making a big bang release, before you release it, just train your product to the very end and release a very mature product, or release it to the market and let your product to learn it. With some companies that works, with some companies it doesn't work. So you need to be careful about that, how you are training your data. And where to store your data is also important as well, from accessibility, security, and performance perspective. If you have hundreds of thousands of pictures, if they are stored in the cloud, if they are PII, if they are personal information for the cloud. So when you're accessing the cloud, you probably need to reach that data quickly. So you need to think about all these kind of things, and you need to think about the performance as well. So where you store data is also pretty important. Questions? Rapid improvements, changes in technology. I can guarantee you can start working in a project in 6 months, lots of things have changed, and you need to keep up. So software is changing very quickly, but AI is, I think, both the theory itself and the projects, the free projects, the freeware projects or platforms change as well. Platform, there's big platform wars over there. Still, we can't get over the cloud wars. We have Azure, and we have IBM, we have AWS. If you look into the market, there are lots of platforms. You have TensorFlow, IBM has one, Microsoft has one. There are like tens of platforms in there. I think 2 days ago I read an article. It was saying that the best 13 AI platforms, so that's the number they could reduce to. So you need to be careful about the platforms as well, which platform you are choosing. The platform you're investing right now might not be valid in a couple of years. So be ready to change it. Capability is another thing. I think there's not enough capability right now in AI, because especially testing in AI, because we are all learning. And there are people who know it better, but they're not really maybe experts, I will say. It's really hard to find the people who knows how to work with these kind of platforms and how to test it and how to implement it. And actually, it's really hard to find business how to use it, because most of the time, what you find with the businesses is AI is shiny. Somebody read it on the newspaper. It's great. My mate, who's the CIO over there, is using it. We definitely need to have an AI. Yes, but what is the problem you want to solve? At some point, you might find out that it is just a hammer and everything is a nail, which actually makes things far more, just your point, just will take the things far more complicated than it's need to be. So be careful about that. The capability is not really there, I would say, yet. And understanding of business with AI is shiny. It will save me a lot of money, but not really. Remember the first days of, there are some faces who can remember. Remember the first days of test automation, just going around, and it was always like, well, test automation, I won't need to spend a lot of money in testing right now, so everything will be great. Well, not exactly. So beware of the hype.
So, which platforms can you trust that your training data is actually not being scraped or used or accessed by others?
If you ask them, probably all of them.
Yeah.
I think one of the platforms which is relatively widely used is just very open, TensorFlow. You can use this free. It's been updated very often. There's a big community using TensorFlow. So TensorFlow, I can suggest definitely. I think IBM is coming up with a new one. And there's a Microsoft one which you can use, but the other two are paid mostly. I think IBM has an API. Sorry, IBM has an API, exposed API.
I think they're exposed as being acquiring their customers' data. That would be such an outrage, and this is such a key differentiator product that they just lose all their customers.
It is.
So I think that risk to the reputation of the business would be so high.
And so we're going to trust that they actually think far enough ahead, like Volkswagen did, not to do something that's untrustworthy.
Well, we do some things already with security of our data. Right? We're putting programs up online. All the cloud providers typically say no one can see your data, including us.
Yeah.
And so I think that's going to guarantee you
We're going to get there.
But they'll also be transparent and say, here's what we do, here's how it works.
Yeah. And Azure IBM cloud-based solutions, platforms actually promise exactly that. If you are using TensorFlow, you probably need to have a solution about security and cloud. But all these platforms comes up with these solutions. So if you're an enterprise, you probably don't want to deal with that. You just want to go for an end-to-end solution, which you can, trust IBM or Microsoft for the security. Because imagine that you are having image recognition, you have hundreds of thousands of faces. A leak will be catastrophic. Any questions? Here are my conclusions. Our robot overlords are still far away, but AI is a reality. So hopefully we won't be killed by robots in the next couple of years. Our jobs will change, definitely, but hopefully we won't be living out of Centrelink because we can't find a job in the next couple of years. But it's a reality. So it's coming, it's there, especially in the narrow AI area, it's there. Start from somewhere, I would say. AI testing might be scary because there are lots of unknowns. And if you are not very strong from a technical perspective, it can be a little bit intimidating in the start. But it's an opportunity. I think it's, again, first come will actually, the persons who will be involved in that will have a great opportunity in the next couple of years in the market because they will be able to get the experience. Training data is really, really important. This is basically one of the biggest, one of the things I think, one of the training data that I've seen sold for, how much money, I can't actually remember how much it was, but it was millions, was, you remember the robot cleaner that one of the companies actually launched a couple of years ago. What was the company's name? I think Roomba. It was Roomba, I think. Might not be. I don't know. But what happened is they were in negotiations with IKEA to sell the home plans, because these robots are mapping your houses, right? And they map millions of houses. So imagine IKEA has this training data and puts into its AI saying that this is how the houses look like in different places in the world, and create me the perfect products, let's say. Then here you go. So training data is very important. It should be realistic, and it is expensive though. If you are creating it from scratch, I would say think twice. Probably it's somewhere somebody's selling it. If you're a big enterprise, think about that. It's an opportunity itself as well. Creating training data is an opportunity, is a business opportunity itself as well. So definitely something we need to keep an eye on. Different challenges, as I mentioned, AI testing has different challenges. I think it will rely a lot on exploratory testing. Testing AI with AI is another option. But then how do you know? Because testing AI is challenging, I think, because you are trying to mimic end user, and end user is basically a human personality. And if you are able to mimic a human personality, you already tested Turing test. Congratulations. So it's really hard to do that. But there are some ways, at least in a narrow level. How AI help testing is another topic, I think, which also needs attention, but we won't be covering it here. All the AI related tools definitely help testing, especially if you want to do user level testing, and if you want to do high volume testing, I would say, just to make sure that you're covering most of the edge cases. So you can use some algorithms to find these edge cases. But again, you need to capture the user data, training data to find those. That's basically it. I don't know if I was on time. No, not bad.
One question.
Sure.
About the training data. So how portable is training data when you consider that the solution that you make or other people might make for the same sort of problem might be completely different? I thought training data would be too tied to how you use AI to actually solve the problem. So you can't sort of sell it unless you're selling it to someone who's done exactly what you've done. Is that right?
Yeah, I'm thinking right now. Two things, I think. One of them is, if you want to create a training data that you want to sell, probably you want to create it in a very common medium, like JPEGs, if it is image recognition, or MP3s, or lossless sound recording, if it is voice recognition. So I will suggest, I will think that you will actually create it in a common platform. So for the people who are buying your data, it should be easier to process it, if they did not already started developing their product on something completely different. And I think it also depends on the platforms. So it depends on what you can, how you can leverage platforms, like how big data you can put in there, or some platforms might have direct support to some data structures. I don't know really. This is a very complex question, but it's a good point. But I will say, so normally what happens is training data is most like JPEGs in most of the places. So you can have photos, JPEGs someplace, and if I'm smart, if I'm creating an AI product, then we'll probably use a common medium that I can actually access, because if I'm using cameras, I don't want to get all this information converted to something and then send it to me. I just wanted to get this information straight away. That's my take. All right. Thank you.